All right, everybody. As promised, I wanted to make a video covering the material on your first test since it took so long to get that back to you. So I'm going to try to do that. Since this is going to be a really long video, I'm not going to start over if I make a mistake. So hopefully this goes relatively well and I don't have any problems with this software. Anyway, let's just get started. So if you want to find the inverse of a function, the first thing that you want to at least think, if not write down, is we really want to think about this function using two variables, x and y, instead of function notation. So this isn't really a necessary first step, but that is what we're thinking. The real first step is the fundamental one when dealing with inverse functions, is you interchange the variables x and y. So everywhere you see a y, you replace it with an x. Everywhere you see an x, you replace it with a y. Now we have to solve for y just using basic algebra in this case. Depending on what the function looks like, this can take a little bit of work, but it's not too bad. In this example, add 2 to both sides, and we've solved for y. Now what you really want to do to use proper notation is switch back to function notation, and we'll say that the inverse function, so h inverse of x, is 5x plus 2. There we go. So that, I hope, is the correct answer to this question. I'm going to have to clear my screen because I'm writing on my monitor with a tablet. So I'll try to talk for just a second. You can pause the video if you need the solution, but I have to trash that. Okay, so if we go down to the next question. So number 2, there's actually very little to talk about. There's no work to show. So what we have to do is think to ourselves, well, what does the line y equals 2 look like? And that's a special case from Algebra 1. That's a horizontal line. So if we are perpendicular to a horizontal line, that means we're a vertical line. Vertical lines are also special cases. Vertical lines have equations that always say x equals. So in this case, x equals 4, and we're done. Nothing else to do in this particular problem. So if you want to see it, pause it, but otherwise that's going away. Now number 3 does require a bit of algebra, just review from prior classes for the most part. So we want to solve this by factoring. Everything's already all on the left-hand side. It says equals 0, so you can get started. You want to look for a common factor. There is a common factor here, namely 2. So we have 2. Oh, goodness gracious, the common factor is 2. When we divide by 2, though, hopefully I can do basic math today, we get 3x squared plus 8x minus 3 equals 0. So hopefully this factors. Now if you're just going to do this in your head, which I would instead of doing splitting the middle or something like that, I always treat these as just fill in the blank problems. This blank multiplied by this blank has to give you 3x squared, and then this blank times this blank has to give you negative 3. Here, I'll underline this twice in case anybody is colorblind. So this one's not too bad. Since 3 is a prime number, there aren't all that many possibilities. 3x times 1x gives us 3x squared. And let's see, negative 3, I believe that's going to be a plus 3 here and a minus 1 here. Now I don't just automatically know that that's the correct answer by looking at the blanks. I have to juggle to see this middle term and see if that's correct. So you look at the outside terms, 3x times 3 would be 9x. Negative 1 times x is negative x. And 9x minus x, that is the 8x that we want in the middle, so I know that everything's in the right place. Once this is factored, a couple people didn't do this on the test. If we're solving an equation, make sure you finish solving. Set each factor equal to 0 and solve those resulting equations. So we get x equals 1/3 or x equals -3. So that's how you do that by factoring. If you want to look at the work, please pause the video. Otherwise, on to the next question. And it's been a while since we've done this, so I don't really remember everything that's on this test. So hopefully I don't mess any up. All right, when simplifying radicals, a good rule is the number 150, 15 times 10, should not cross your mind, nor should 90, 15 times 6. Now, you can do it that way, but you're going to end up working too hard. Rather, when we use the distributive property here, so we're gonna distribute. Think about the factors of 15, the factors of 10, and the factors of 6. That's a little bit easier. So 15 times 10, rather than thinking about the number 150, I'm just going to think about factors. Well, 15 is 3 times 5, and 10 is 2 times 5. And for that second arrow, the distributive property, same thing. 15 is 3 times 5, and then 6 is 2 times 3. So when we're simplifying square roots, if I have 2 copies of 5 and I multiply them together and then I take the square root, I'll get back to 5. And you want to think about it that way. Yeah, I know 5 times 5 is 25, and then when I take the square root, I get back to 5. But actually doing the multiplication and getting the number 25 is not important there. So 5 times 5 is some number, and then when I take the square root, I get 5. So 5 is now outside of the square root. And inside of the root, I still have this 3 and 2 that's nothing to do with, so 3 times 2 is 6. Now, over here, we have 2 copies of 3, so 3 times 3 is something, and then when I take the square root, I get to 3 again. So I'm going to take the 3 outside. There's already a 2 here. 2 times 3 is 6. And inside, there's a 5, there's a 2, nothing to do with. So they're going to stay there. And 5 times 2 is 10. So 2 steps here. Key hint, think in factors instead of actually doing a bunch of multiplication. It's a lot easier. So pause that if you need it. Otherwise, we'll move on. All right, dividing with square roots. This is where you need a very common trick that's going to show up in multiple contexts with complex numbers and in trigonometry. Here, if we have something in the denominator that we don't like, namely the square root, you would just like to multiply by the square root of 2. That's how you deal with the simple examples, but given that this is a fraction, that won't work. So you do have to know this rather specific trick. I have to multiply by this conjugate 3 plus the square root of 2. Now, conjugate's normally a word that gets used when talking about complex numbers, but this is the same thing, so I don't mind using it here. The idea is this is minus, its conjugate has a plus. If this was a plus, I'd multiply by 3 minus root 2. And if I do that in the bottom of the fraction, I have to do it in the top of the fraction as well. Now, the reason that that trick works is that it looks like we're going to have to do a bunch of work here. The numerator is actually really simple. So I'm not going to draw all the arrows for the distributive property because it's going to look really clunky. So just imagine all of the arrows you'd have to draw. You'd have a 3 times 3, which is 9. You have a 3 times root 2, and then you have a 3 times negative root 2. So you have positive 3 root 2 and negative 3 root 2. Those cancel. Now, negative root 2 times positive root 2 is minus 2. Minus 4, if I remember correctly, was a relatively common mistake. The square root of 2 times the square root of 2 is the square root of 4, and that's 2. Now, the numerator, there is a little bit, we just use the distributive property again. So we have 3 multiplied by the square root of 2 plus the square root of 2 times the square root of 2 is 2. So the only thing we need to do is simplify the denominator. 9 minus 2 is 7. Rather than write this again with my annoying pen, I'm just going to write a 7 there. And that's a perfectly fine final answer. So if you want to see that, pause it. Otherwise, we'll move on to part C. Okay, here we're multiplying complex numbers. So we just use the distributive property yet again. 4 times 2 is 8. 4 times 3i is 12i. Negative 5i times 2 is negative 10i. And negative 5i times positive 3i is negative 15i squared. So now we combine like terms. 12i minus 10i is going to be 2i. I'll write that down in just a second. But for the real part, we have 8, and this last term does simplify to a real number. Since I squared is negative 1, we have negative 15 times negative 1, making this plus 15. So 8 plus 15 is 23, and then as I said before, 12i minus 10i is 2i. There we go. Pause that if you need it. Otherwise, next problem. All right, more complex number stuff. Here we need that conjugate trick again. To divide complex numbers, you need to multiply by the complex conjugate in the denominator and in the numerator. And here it's a matter of the distributive property. Boy, we've used that a bunch of times. And the denominator, even though it looks like it's going to be kind of ugly, is actually very simple. Complex conjugates are nice like that. 1 times 1 is 1. 1 times 2i is 2i. 1 times negative 2i is negative 2i. So we have 2i minus 2i. Those cancel. There's not going to be an imaginary part in the denominator. Negative 2i times positive 2i. You could simplify it in your head if you wanted to, but just for emphasis, I'm going to write negative 4i squared. In the numerator, distribute, we have I times 1, which is I, and then I times 2i, 2i squared. So let's just clean this up a little bit, noting that I squared is negative 1. So this I squared is negative 1, so this term becomes negative 2. That's the real part in the numerator. Negative 2, I still have I there. And in the denominator, since I squared is negative 1, this is 1 plus 4, or 5. There we go. That's how you divide complex numbers. Okay, so logarithms and exponents that lead to logarithms. You really want to see this as 3 distinct parts. If you know how to do it, it takes no work, but just to show the thought process, you want to think about this as 16 raised to the 1/4 power, and then you're going to raise that to the 3rd power, and then you're going to raise that to the negative 1 power, because 1/4 times 3 times negative 1, that is negative 3/4. And since you multiply fraction, or since when you multiply exponents, when you raise a power to a power, I haven't changed anything. But I'm going to take this one step at a time. So 16 to the 1/4 power, that means the 4th root of 16, which is 2. 2 to the 3rd power is 8. And then 8 to the negative 1 power is 1/8. So if you think through this as 3 distinct steps, you don't show any work, you just write 1/8 and you're done. So pause that if you want to look at it. Otherwise, we'll do the logarithm question. So log base 927. You think to yourself, kind of in the similar strategy as the last problem, I want to raise 9 to some power to get 27. So I can't do this with just a nice whole number, because 9 to the 1st is 9 and 9 squared is 81. So I'm going to have to make 9 smaller first and then raise it to a power to get 27. So the thought process is, if I raise 9 to the 1/2 power, I would get 3, because 9 to the 1/2 is 3. Half power means square root. And then if I have 3 and I raise it to the 3rd power, I'll get 27, because 3 times 3 times 3 is 27. So there you go. That's the answer. So first 9 to the 1/2 power to get 3, then 3 cubed to get 27. Pause that if you want to draw the diagram yourself. Okay, completing the square, as you guys know, my favorite method for solving quadratics. If they don't factor, I despise the quadratic formula. So we need a little bit of preliminary work here. You can do it in multiple steps. We're not solving by factoring, so I don't want to make this say equals 0. I want to move the constant term to the right-hand side, and I want to move the 4x squared to the left. So if I move 4x squared to the left, 8x squared minus 4x squared is 4x squared. I have 8x. Since we're completing the square, I leave a suspicious blank space, and I add 1 to both sides. Now, in that suspicious blank space, oh, sorry, we're not ready to fill that in yet. Oh my goodness, I got ahead of myself. When you're completing the square, you don't want to see 4x squared. This has to say 1x squared. So before I worry about my suspicious blank space, I'm going to divide both sides of this equation by 4. All right, x squared plus 2x is equal to 1/4. Now I worry about my suspicious blank space. So half of 2 is 1, and 1 squared is 1. I add that number to both sides. And that's the key step when you're completing the square. I factor the left-hand side, which, if you've done this correctly, is always going to factor very nicely into a perfect square, and you're not going to have to think too hard about factoring that side. 1/4 plus 1 is 5/4. Now we solve this equation just using basic algebra. Take the square root on both sides. Don't forget, when you take a root, you need plus or minus. And finally, finish solving. So our final two solutions are -1 plus or minus the square root of 5/2. If you wanted to get a common denominator, this would be 1 is 2/2, so this would be -2 plus or minus the square root of 5/2. I'm going to leave it like this, and I don't want to write it again. All right, so pause that if you need to, otherwise. Okay, we want to find this difference quotient by hand. There was another difference quotient problem on the calculator, but this is just algebra notation in all of its glory. So we got to know what the difference quotient is. It's f of x plus h minus f of x over h. That's what the difference quotient is. All right, so we take this x plus h, we plug it into our function f. So we have x plus h squared minus 3 times x plus h plus 2. So this is f of x plus h, and now I subtract f of x. So minus x squared minus 3x plus 2. If you don't put this out of parenthesis in your own work, I guess that's fine, but you better remember to distribute this minus sign. Okay, all over h. All right. Sorry, I dropped my pen. Back to it. Okay. So now we're doing basic algebra in the numerator. X plus h squared, that is not x squared plus h squared. If you write it out and do the distributive property, it's x squared plus 2xh plus h squared. And then distribute here, we have minus 3x minus 3h. Now, I'm not going to write the plus 2. If you'll notice, once you distribute the minus sign, you have plus 2 and minus 2. Those cancel. So I'll just distribute the minus sign, and I'll get minus x squared plus 3x. All of that is over h. Now, as is usual with the distributive property, we already saw the 2's canceled, so some other stuff cancels here. We have the 3x's and the x squareds that cancel. And that's usual with the difference quotient. So let's see what's left. We have a 2xh plus h squared minus 3h. Notice all of those have an h in them, so you can factor that out. And when you do, you'll see that that h that you factored out cancels in the top and bottom, leaving you with the difference quotient, 2x plus h minus 3. It doesn't matter what order you write the terms in, so I'm just going to leave it like that. So definitely pause this one if you missed that question, but otherwise we'll move on. Okay, dealing with a quadratic, probably going to have to do this in 2 parts. I can't really zoom out, so sorry. We'll just do it in 2 parts. All right, where's the y-intercept? To find the y-intercept of a function, you plug in 0, because g of 0 means you're on the y-axis. If you plug in 0, you get -2. So, helps if you change back to writing in a pencil. Okay, so the y-intercept is at 0, -2. Yay. Okay, vertex form. To convert to vertex form, this requires completing the square with a couple of little changes to it. So, step 1. You factor the leading coefficient out of the first 2 terms, and only the first 2 terms. So I'm going to factor out a -2, but only from the square term, and that's going to leave me 1x squared, it always will. In the second term, 8x, I'm factoring out a -2, so minus 4x. Leave a suspicious blank space, close your parenthesis, and then the constant term, -2, just gets pushed off to the side. It's not inside the set of parentheses. It's from here that we now complete the square, and I fill in my suspicious blank space. Half of 4 is 2, and 2 squared is 4, so 4 goes in my blank space, but then I have to balance that number out, and it's not as simple as if you're doing equation solving. You have to realize that this number 4 isn't really a 4. If you use the distributive property, we get -2x squared, which we started with, plus 8x, which we started with. We're not changing anything. And we get -8. So we've actually introduced a -8 in the definition of our function. And if I want to balance out that -8, I have to do so with a +8. That's, well, the key step, I suppose. And now we're done. We have vertex form. We have -2, x minus 2, quantity squared, plus 6. Now I didn't explicitly tell you to write the vertex, but at this point you should be thinking that, all right, vertex form tells me that the vertex is at 2, 6, and we're going to need that in a little bit. Okay, to find the zeros, I'm going to have to clear the screen. So if you just want to see vertex form, pause that now. All right. So the easiest way to find the zeros, especially if you don't want to work too much, which I certainly don't, is to use vertex form. You already did the work for it. You might as well use it. So vertex form was -2, x minus 2 squared, plus 6. So we're going to set that equal to 0 to find zeros. That's why they're called zeros. And I'm going to solve this equation, which I can do with basic algebra. So don't work too hard on this. Subtract 6 from both sides. Divide by -2 on both sides. Take the square root on both sides. Don't forget the plus and minus. And then you're done. 2 plus or minus the square root of 3. So those are my 2 zeros, which are also x-intercepts. They're irrational numbers. I could approximate them on the graph if I wanted to, but you know, it's fine. So if you need to see that, hit pause, and we'll draw the graph real quick. Okay, so this is just putting all that together. I hope I can remember where everything was. Hopefully you have it on your paper. The vertex was at 2, 6. 1, 2, 3, 4, 5, 6. There we go. Here's the vertex. Now, our parabola is pointing down because it started with a minus sign, and it's been scaled by a factor of 2. So whereas a normal parabola, or the parent function parabola, goes over 1, down 1, this parabola is going to go over 1, down 2. Over 1, down 2. The parent function parabola, so just y equals x squared, is 2 and then 4, okay? But we're not going to go down 4, we're going to multiply that by 2. So we're going to go over 2, down 8. And that does pick up our y-intercept as well. We already knew that though. So I'm probably not going to be able to draw this very well with a tablet pen. My apologies. This is actually a pet peeve of mine with students. They make their parabolas look like they have like a V shape. Goodness, graphing on this thing, it's not much fun. All right, do the best you can. You can do better on paper than me. So don't hit pause because that parabola is very ugly. And let's move to the next question. Okay, this is the bonus question. I don't want to do this because it's bonus and this video is long enough already. So that's the non-calculator portion of your test. So you definitely need to practice a lot of those arithmetic skills if you messed up on some of those complex numbers, logarithms, square roots. Completing the squares, a really, really, really important algebraic technique. We used it here when converting to vertex form, and we used it when we were just solving an equation. Difference quotient, guys, this is the first lesson in calculus, more or less. All of this, or most all of this, will show up on your quarter one sort of big test that we talked about in class. Anyway, I'm not going to make a video on the calculator part of your test because I made 2 videos about those topics already, and that's really just following the procedure in the calculator. So for the calculator portion of your test, see the 2 YouTube videos that I already made. Anyway, sorry it took so long to get the test back to you. I hope this helps, and if you have any video suggestions or requests, please just let me know. Otherwise, see you in class.